Good morning, everyone. Thanks for attending this webinar co-organized by Vewd and Dataxis. The presentation will be dedicated to the challenges that are faced by pay TV operators with the evolution of the market and of functionalities that can be provided. And we'll try to understand how operators can overcome the limitation of the set-top box hardware. So the regional focus of the presentation will be set on Latin American countries, and the webinar will last around 30 minutes with an additional 10-15 minutes at the end for the questions and answers. You can type your questions during the session, and they will all be answered at the end of the presentation. I am Saeva Nebier, analyst at Dataxis. We specialize in market research and conferences on media topics. Mako Fratolin and Chris Carter, respectively head of operator product and product marketing manager, will provide analysis and insights on the strategies that can be deployed to address the UX issues. And I will let them give you more details about Vewd's activities later on in the presentation. Let's start first with a short market update. So if we look at the region's characteristics, we see that Latin America comprises of around 650 million inhabitants, around 200 million households. The TV penetration is quite high, at 93% in 2019. And in comparison, the pay TV penetration does not seem that important in the region. And it comes in part from the importance of piracy, which is competing with the traditional pay TV offers. We see also that the number of pay TV subscribers is not progressing as fast as it used to be. And this is due to the increased competition of newly launched offers, but also to the economic difficulties that are faced by some countries in the region. When we look at the access technologies that are used to distribute pay TV, we see that DTH is becoming less attractive. And this comes in part from the fact that some operators are transferring their base to other accesses, other distribution accesses. And so on the other side, what we see is that IPTV and OTT pay TV services are gaining subscribers, and their offer are generally more comprehensive with more sophisticated features. And these two last accesses also go along with the rise of internet connectivity that is observed within the region. And this is illustrated here. So we observe a growing penetration of mobile and fixed broadband services. And what is striking in this growth is the increase in quality in bandwidth speed that derives from the technology that is used. So we see on the chart on the right that data only, which accounts for USB data cards and DSL accesses, are declining, while fiber observes the strongest growth, and it is followed by cable. So these trends are observed in almost all countries of the region. And overall, we see that the penetration represents around 50% of households in the region. It's expected to continue growing to catch up in the next years. So we see that broadband access and the way it is accessed has consequences when it comes to developing OTT services, whether it is to launch a standalone offer or to enhance an existing offer. And this is directly correlated. The SVOD subscriber numbers reached close to 40 million subscribers in 2019, and this represents around 20% of the total households. So the increase has been significant in the past years, and we see here our forecasts, which are following this trend, the fast-paced growth, which is expected to continue in the coming years. And we can note that the growth is catching up on the pay TV numbers, which we saw pay TV subscribers amounted to around 70 million in 2019. And the number of actors is also multiplying. There were only 30 platforms offering paying as VOD content in 2015, and they rose to 66 for the region in 2019. So we are talking about separate services that are competing for viewers. So to sum up the characteristics of the region, the pay TV market and content distribution players are changing rapidly on the impulse of more advanced technologies, the rise of OTT offers and distribution. And it can represent a challenge for operators to adapt to the new standards of the market, which can be more flexibility or advanced navigation features, for instance. But these new functionalities can also be leveraged by the operators to enhance their offer. And these developments that can be made will be the focus of the rest of the presentation. So I will now give the hand to Chris for a more detailed analysis of the UX features.
Thank you, Saeva, and hello to everyone. We've called our webinar Freeing the UX from the Limitations of Set-Top Box Hardware Performance. So why would you need to do that? The problem is that there is a constant stream of new TV services and features launched every day. This means that the demands on the set-top box are growing all the time. Operators have to respond to this in order to remain competitive. Generally, this means that each new generation of set-top box has to be capable of new levels of complexity. But it doesn't stop there. Your user experience in your new set-top box may be state-of-the-art when it's released, but it won't stay that way for long because the evolutionary process still continues after launch. Of course, software updates can be rolled out at extra cost and risk, but the performance and capability of the hardware in the home is fixed, limiting what's possible. This is a major competitive disadvantage for operators compared with the always up-to-date services delivered by pure OTT providers. OTT providers update their apps whenever they want, plus they rely on users to provide hardware so they don't have to bear the cost of upgrades. So how can operators with managed hardware compete with this? Today we'll look at solutions to this problem. Before we do that though, here is a run through of today's agenda. We've already heard from Saeva on the status of the market in this region, and we've had a brief introduction from me. So here is the list of remaining topics for the day. First, I'll give a very short introduction to Vewd for those not fully familiar with who we are. Then in the UX is in constant flux section, I'll give an overview of some of the features of the market that are driving this constant evolution and the associated set-top box UX requirements. After that, I'll cover the options that operators have for dealing with this constant change. From item 4 onwards, I'll hand over to Marco. Marco will give more detail on how a cloud browser solution can help operators solve the problem of future-proofing their systems. This will come with some example use cases and some things that to take into account when considering a deployment. Then after a brief summary, as Saeva mentioned, we'll take new questions and also go through any questions that have already been submitted. But first, who are we? Who are Vewd? Vewd has been in the TV software business for around 17 years. Until 2016, we were the Opera TV business unit of Opera Software, but we're now a separate company. Throughout our history, our mission has always been to enable customers to add OTT content and services to their TV devices. We do this by providing software that renders any online content on the TV screen. This is essentially what Vewd Core, our most famous product, does. Over time, we've added more products to our range. So today we help our customers more generally to exploit the opportunities created when TV devices are connected to broadband. We won't go into the details of all these products, but you'll see an example today. In this particular slide, we show the type of devices where our technology is used. Not surprisingly, we are deployed in smart TVs and set-top boxes of all kinds. We also have some business in in-car entertainment systems, as these share some of the same requirements as TV-connected devices. So what does this mean in terms of numbers? We are a global company of over 200 people with development mostly in Europe. In addition, we have teams local to our customers in all the major regions. For Latin America, our key account management is based in Brazil. With deployments in 170 countries, you can see that our technology is used in most corners of the world. Owing to our presence in volume consumer devices, we deploy around 40 million additional units each year. That gives us an install base of around 300 million units. So as well as providing device technology, we also represent a huge platform for content distribution. Anyway, enough about us. Now we move on to a short summary of typical things that are causing the constant evolution in the user experience that I mentioned before. As we saw in Saeva's presentation, the number of OTT apps grows continuously. New apps are constantly being launched. At the same time, a small number disappear. This chart is for the US and of course shows the same trend. So as we can see, operators need to constantly refine their offering to make the latest popular apps available to their subscribers. Of course, even if there are no new apps, the popularity of different apps varies over time. No doubt Disney+, HBO Max and Peacock will change the order in this US slide for 2020. So how apps are promoted needs to regularly vary in order to keep the most popular apps in front of subscribers. The other characteristic of apps is that they are often upgraded as providers improve their offerings with new features. Operators need an efficient way to manage this dynamic. In addition, it's not just the apps, but also the UX itself that needs to evolve. Consumer expectations change all the time as they interact with other devices. They bring these same expectations to the TV. Plus, over time, new service categories appear. Originally, operators only had to provide live TV and a guide. Then, with widespread broadband availability, operator VOD became a requirement. Similarly, broadcasters take advantage of the same trend to add catch-up and restart services. These also now have to be supported. And of course, SVOD and AVOD services came along and they have to be included as well. More recently, gaming is becoming a feature, and in the future, no doubt more categories will come into existence. These category changes impact not only the content, but also the structure of the US that operators need to offer over time. The final driver is the availability of low-cost cloud computing. This creates opportunities to exploit the vast amounts of data that operators have access to or can generate. Some of these opportunities are operational only, but many have a direct impact on the consumer's experience of the service. They may affect how the UX should be laid out, how it is structured to shorten the route to content, which types of services are featured more prominently, and other variations that insights from the data might suggest. Other data-driven services may also impact the UX. For example, responses from a voice assistant may need to be placed on the screen. These things are driving a need for continuous upgradability of the UX. So what if it could be done? What if the set-top box UX could be updated continuously? I've listed some of the benefits here. Firstly, your app catalogue can be kept always up to date with the latest service launches, making sure that everyone has access to the latest apps. New services and offers can be deployed across the entire install base, maximizing take-up. New business ideas can be tried out and tested before rollout across the footprint to ensure that the investment is really worth it. Having all subscribers on the same version of apps and services makes support easier and less costly. And possibly the most significant, software upgrades or box swap-outs are not necessary to maintain the service at the current state of the art. This saves both CapEx and OpEx, as well as providing a better service all around. So how can it be done? Here are the three main options. The first is the typical connected set-top box model. The set-top box receives both broadcast and online content and delivers them to the TV in a combined UX that is embedded in the box. In this case, upgradability can be achieved by using cloud services to generate some of the elements of the UX. For example, the content catalog, recommendations, promotions, and app store, and other things. The box has a fixed framework embedded in its UX to support this. Apps and services all run in the box, so it has to have sufficient power to support that. Ideally, the box also has to have the power to support any services that may be offered over its lifetime, which could be 8 to 10 years. Generally, though, this is not possible for cost reasons. In any case, upgrades to support major new features may require an update to the software in the box. This can be costly and time-consuming owing to the integration and certification that has to be carried out. There is also a software upgrade process that has to be rolled out. Generally, this is only possible for a few years after the box is first deployed. Over time, it becomes more and more difficult to maintain fragmenting software profiles. In summary, this solution can be personalized and it is upgradable, though maybe not for the whole lifetime of the box. Its cloud load is minimal, but the baseline cost of the box is higher. The second model uses a set-top box that contains a thin client. The box in this case receives the OTT service together with its UX transcoded so as to look like just another broadcast channel. This greatly simplifies the demands on the set-top box in terms of software complexity and of hardware cost. The trade-off is that a virtual set-top box has to be created in the cloud. This decodes and decrypts the incoming video, adds the corresponding UX, and then transcodes and re-encrypts everything before sending it to the home. The benefit of this is that the virtual set-top box is fully personalizable and upgradable. The downside is that transcoding is a heavy load on the cloud server, as is the continuous streaming required from the cloud to the box. Both can be costly when scaled. This option is uniquely advantageous for very low performance boxes. Typically, these are legacy boxes, though. It is often difficult to access these old boxes to add the required thin client, either for technical or for business reasons. In summary, this solution can be personalized, is upgradable, and can run on very low-cost hardware, but it can be expensive in terms of load on the cloud. It may also present practical difficulties in those markets where it is best suited. The final option, and in our view, often a better compromise, is the cloud browser model shown here. In this case, the broadcast and OTT video are not intercepted in the cloud, but are sent direct to the box. The video retains its content protection, maintaining security. Other streaming features stay intact, and the video is decoded in the box in the normal way by the device's internal decoder. If necessary, the thin client's built-in software can be used to play any media types not supported by the hardware. At the same time, UX is generated in the cloud, based on the operator's rules. This is then compressed and sent to the box to be combined with the video for display. As UXs are relatively static compared to video, both the cloud bandwidth and processing load are low, and hence much less costly than for the virtual box case. The thin client, as it is essentially an expanded media player, can run on any modern low-cost set-top box. As all the non-video processing is done in the cloud, the service is fully upgradable, and as with all these solutions, can be personalized. If the operator has other services that absolutely must run in the box, then these can easily be integrated with the thin client, assuming the box has hardware that supports them. This allows the operator to offer a scalable range of boxes supporting different segments of the market. So in this case, the solution can be personalized, it is fully upgradable, it can run on almost any set-top box, and the burden on cloud infrastructure is low, the best of all worlds. Of course, this final option assumes that there is a cloud browser out there that can be used to implement it. At this point, I'll hand over to Marco to tell you about such a solution from Vewd.
Yeah, thank you very much, Chris, and good afternoon, everybody. This is Marco Fratolin speaking. Let me take over the screen sharing. I think now you should see my slides. So as Chris explained, at Vewd, we believe that the cloud browser is really the best approach to take advantage of the cloud performance and scalability, and at the same time contain costs. So as a cloud browser, our Vewd Atom is made by two parts. There is a modern web browser engine running in the cloud or on the server side in general. And this is based on latest Chromium engine with our proprietary patches. And then the second part is a thin client running locally on the device, the target box, which receives the encoded UI. And the combination of these two elements enables the delivery of a unified HTML experience on any hardware. So let's have a look at some of the key details of Vewd Atom. So the first important aspect is that Vewd Atom supports full HTML5. So it is basically like having the latest Chromium version on every device. This is possible because the latest Chromium actually runs on the cloud, so it can support all the latest frameworks and tools that web developers need to use to implement UIs and apps. It supports video in terms of HTML video tags, video, audio. We also support Canvas, which is very important for applications such as games. And we also support MSC EME APIs, which are, of course, used more and more in modern OTT apps. And especially this feature, MSC EME, is possible thanks to our hybrid approach where we separate the audio-video content and the UI. And I'm going to tell more about that in a minute. If necessary, we can also support persistent memory for cookies. There are cases where this is not advisable, but if necessary, it can certainly be done. And of course, the benefits of full HTML5 support on every device are very, very clear. HTML5 support is fully transparent for most of the already existing UIs and apps. In case of a new UI or in case of maintenance of an existing UI, the costs are much lower because the UI has to be adapted and verified only on the server browser. This means that you can expand the footprint of the target devices, including also low-end boxes that wouldn't be able to run the same UI and applications natively. The time to market is shorter, and the innovation can be faster because the update process only requires to basically load a new URL on the server browser. So it's very similar to a normal OTT app, and it does not include complicated firmware update for the set-top box. And of course, HTML5 support means that Vewd Atom is pre-integrated with the other HTML5 products from Vewd, specifically our UI called Vewd OPEX, Operator Experience, and all our apps. A central aspect of Vewd Atom architecture is this hybrid approach, which means that the video stream and the UI stream are independent. So basically, the video stream, which means that the movie or the linear TV channel or the video clip in general, including, of course, audio, video, and subtitles. So the whole video is independent from Atom and is basically streamed directly from its original server, could be the operator Vewd store or the OTT content partner, and it goes directly to the client. Vewd Atom doesn't touch that, which means that Vewd Atom doesn't introduce any requirement for transcoding or additional CPU and bandwidth usage. While the UI is rendered in the cloud browser, and then it's encoded in H.264 or JPEG, depending on a couple of detailed considerations, and then it's also streamed to the box. Of course, the video content takes most of the bandwidth, so the additional UI stream is much lighter. In the UI streaming, we also take advantage of adaptive bitrate protocols. We also support variable frame rate, so that we use only the bandwidth that is necessary based on what is actually changing in the UI. This means that if the end user is not interacting with the UI, or if the UI on screen is not changing, Vewd Atom consumes zero bandwidth and also zero CPU. So this allows us to offer a very efficient server infrastructure. The UX is always responsive. And of course, it is still possible to mix and blend graphics and video, as all modern UIs and apps do. So we support picturing graphics, alpha blending, video starting in the background while the end user is navigating through the UI, and all of that. At the same time, this solution can work over the internet. The basic rule is that if any IP connection could be on a managed network or over the internet, if any IP connection is good enough for OTT video, then it's also good enough for Vewd Atom, because the additional bandwidth needed for the UI stream is much lower than video. And last but not least, the fact that Vewd Atom doesn't interfere with the video means that the video security is kept intact. So encryption and DRM are not impacted. A question that we get very often from customers and partners is, what about latency? Because of course, having the UI rendered in the network or in the cloud does include some extra latency, or it seems to do so. Now let me explain why this is not a problem. So if you think about an application running locally on a set-top box, there is a certain latency due to remote control handling the application running on the browser and all the operations involved with that. Now, if you move that application on the cloud, then of course you are adding two elements to the latency. One is a network round trip, because the input event has to be sent to the server and the UI has to be sent back. So those are positive contributions, even if they are almost in all cases around 100 milliseconds or a little bit more, so it's not a big impact. But at the same time, the HTML5 application is much faster because it runs on a powerful server. So the additional speed that the application gains thanks to the cloud browser compensates the extra latency added by the previous elements. So in basically all cases, this extra performance gain makes the overall Vewd Atom latency comparable with the normal application latency running locally. But we have also seen cases where actually the application is overall faster when running on Vewd Atom, because the extra performance gained by the application running on a server is much higher than the extra latency due to the network. So the takeaway here is that, yes, from a technical perspective, there is some more latency, but this is never a problem in typical cases. And then a very important element in Vewd Atom is, of course, the thin client. And the key word here is flexibility, meaning that our thin client can run on very low-end boxes, so the minimal hardware requirements are very low, but at the same time, it takes advantage of the hardware capabilities that are there. So it uses the native codecs, DRM, and streaming protocols. And if the set-top box hardware allows that, then we can enhance the Vewd Atom client with our Vewd Media Player, which then offers support for a complete feature set of ABR and DRM, and it's already certified with the large network of Vewd content partners. And if the set-top box allows more, then we can also combine Vewd Atom with native OTT apps. So the key point here is that the thin client will do what is optimal on the target box and nothing more, which means that you get a harmonization of all the different boxes to run the same HTML UI on all of them, but you don't have the risk of pushing all of them to the bottom and basically wasting hardware capabilities. So let's have a look now at some examples of use cases where this technology has been used. So the first example is the most extensive. So basically, you can use Vewd Atom to implement the complete set-top box UI. So the whole user experience of the box can run over a cloud browser. Here in this slide, we are illustrating that with our own UI, Vewd Apex, but of course, the example is valid for any third-party UI existing or to be designed. And this means that anything that appears on the screen of the set-top box comes from the cloud browser. So this is one approach. Or the other approach is to keep the basic UI on the box, maybe because it is already there, and use Vewd Atom to offer additional enhanced services and features. So for example, you can use Vewd Atom to deliver HTML5 OTT apps on top of an existing UI. In this case, we illustrate this with our Vewd App Store, where we support the most relevant HTML5 OTT applications for every region. And of course, it's much easier to add and update applications based on the cloud browser instead of natively on the box, because all these applications have to be validated only on the cloud side. On top of that, there are other additional features that are easily deployable on top of Vewd Atom. So for instance, you can enable the set-top box to show or display the results of a voice assistant, which very often come in HTML form. You can also include the interactive advertisement or interactive banners and dialogues, both in the UI or in combination with the linear TV channels. And this is typically HTML content that is too costly to optimize and adapt for every box. So it's very useful and very efficient to just validate it on the cloud side over the cloud browser, and then making sure that it works in the same way in all the devices. Another example is games, specifically casual games. Our experience with the smart TV app stores show that casual games are one of the top categories of apps that the end users use. And of course, in all these examples, we are not talking about basically vital features for a set-top box, but these are all very important enhancements and value add that the cloud browser makes very easy to add to increase the stickiness of the service, and in some cases the ARPU. And then last but not least, especially in Asia, it's quite successful, the model where the cloud browser is used to support T-commerce, so basically shopping on TV. And as you can imagine, an HTML5 application to support a complete the shopping experience is quite complex with many different use cases. So it's very efficient to support it via cloud browser instead of performing porting, integration, and validation of the same application on every different box. And then I want to conclude this presentation mentioning a couple of considerations about deployment, because of course a cloud browser includes a cloud part, which can be on public cloud or on premises. And as everybody can imagine, there is no one-size-fits-all approach. Every case is different. So before entering into details, I want to encourage everybody in the audience to get in touch with us, and we are more than happy to discuss specific cases. But in general, we follow a three-step process. The first step is to estimate the workload that a specific use case will generate. And of course, to do that, we have to answer together with the operator a couple of questions in terms of number of subscribers, number of concurrent users, time spent in front of the UI, and so on. This is, of course, very different for different operators and use cases, but usually it's not too hard to identify good answers to all these questions. Then, once this is done, we move to the second step, which is calculate the server capacity needed to support that workload. And this we can do based on our knowledge of the system, our reference data coming from our deployments and tests. So we can go from an estimated workload to an estimated needed capacity. And then the third step is to plan how to deploy such capacity. And as I mentioned, of course, the main two options are either on-premises or cloud, but very often the most efficient approach is a mix. So we have seen that what works very well is to, for example, start with the public cloud because it gives you more flexibility. It gives you like faster time to set it up. And then over time, then you can move into an on-premises approach to save costs for the average workload. But then you can still rely on the public cloud for auto scaling and handling peaks, because Vewd Atom does support a mixed deployment model. And then I also want to mention that for extraordinary peaks or extraordinary circumstances, Vewd Atom also offers the possibility to basically reconfigure the UI resolution or even the frame rate, because this can have so reasonably low impact on the user experience, but they can double or even more the CPU capacity. So, for instance, if you go from 1080p UI to 720p UI, the impact on the user experience is fairly low, but you basically double the CPU server capacity to be able to handle peaks. And then when you do the math and you run through all the numbers, the conclusion is almost invariably that the total cost of ownership for a cloud browser installation, specifically for Vewd Atom, thanks to the efficient architecture, is lower than the combined costs of deploying a better hardware, which means increased capex for the boxes, and the ongoing effort of continuously adapting and maintaining and updating the UI on multiple platforms. So in a nutshell, Vewd Atom is a cloud browser that allows you to deploy the same HTML experience across all the devices. And this has a number of benefits, which start with the cost reduction, both on the devices and on the UI maintenance approach. It allows you to do more updates faster, making the device future-proof. It allows you to support more content, specifically HTML5 apps. And all of this is done without touching the video security chain. And this was my last slide, so I think we have some time now to answer some questions. So I would like to ask Chris if we have received any questions.
Yes, we have had a couple of questions. If anybody has any other questions, now is the time to ask them. But the first one is about the material from the presentations. Is it available for review after the webinar? And yes, that is the case. After the webinar is finished, you'll get an email containing a link to the presentation and the recording, so you can review it at your leisure. And there is another question about, can we show one of the slides again? Well, I think that's the same. If you look at the slides, once you've received the link to the presentation, then you can look at any one you want again. And another question is, how do you see the migration movement of video users from pay TV operator to SVOD OTT subscribers? So I'm not sure who that's for. So Saeva, can you take that one?
Yes. So there's no. Well, it's not a migration from video from pay TV subscribers to SVOD OTT subscribers necessarily. We see that in the countries where the SVOD OTT launches and trends were the most important, and in particular in the US, there has been migration, but it's also so we have seen incredible. Very important growth of the OTT subscribers numbers and a decline in the pay TV numbers. So we can imagine that it's partly substitution, but it's also linked to the specificities of the US market, where the pay TV subscriptions are very expensive. So the average pay TV subscriptions price are around 100 euros. So flexible offers really have a competitive advantage to make in this market in particular. But in the rest of the world, it's not necessarily the case. So the SVOD OTT offers can be disrupting markets in some regions, but it's really depending on the characteristics of the regions. Even though we see an increase in SVOD OTT numbers all over the world.
Okay, so, thank you. We have another one. Probably this one is for Marco. Says, how do you handle end-to-end encryption from services like Netflix if you are re-encoding from your cloud server to the set-top?
Yes, I can take that. Yeah, that's a very good question. So I think the answer is that we basically don't touch the end-to-end encryption of the video. I assume the question refers to the video encryption. So basically, Vewd Atom has a hybrid approach, as we mentioned, where the video is intact. So the video content, like the movie or the linear TV channel, comes directly from the original video server or the content partner CDN, and goes directly to the box. So the video encryption and the DRM works as usual, so to speak, while the UI part is instead rendered in the cloud. So all the video security and encryption requirements are the same as in case of a native implementation, and there is no transcoding or transcription, as it is sometimes called. I hope this answers the question. Of course, we can get back in touch with the person who has asked that if this is not clear enough, or if we want to discuss more details.
Yeah, okay. So at the moment, that's the final question. If anybody has any others, then they need to ask them now. Otherwise, I think we just thank everybody for attending and thank everybody for the presentations. As I said, everyone will get a link to the presentation and recording after this is closed. And if there are any follow-up questions or if you wish to discuss anything further, you can contact us directly. There's an email address on the screen. Just remains to thank you again.
Thank you.
Yeah, thank you also from me. Thanks, everyone. Bye.
Bye.